All participants are requested to kindly join as soon as possible. All participants are requested to kindly join on urgent basis. We are starting the session in a minute. Respected Vijay sir, you are requested to kindly switch on your camera. Thank you, sir. Good evening, sir.
Good evening. Good evening.
A very good evening to all the distinguished participants, dignitaries, and esteemed resource persons. With profound respect and immense pleasure, I, Gaurav Verma, Assistant Professor in the Department of Mechanical Engineering, extend a warm welcome to each one of us. On behalf of United College of Engineering and Research, Prayagraj, to the AICT Atal 6-day online faculty development program. We are gathered here on day 3 of this FDP on advanced manufacturing for innovation, integrating additive technology and sustainable practices. The initiative organized by Department of Mechanical Engineering UCR stand as a testament to our continuous endeavor towards academic excellence, capacity building, and the integration of emerging technologies into teaching and research. Conducted this program under the auspices of AICT Training and Learning Atal Academy. adds to its prestige as Atal Academy is committed to enhancing the professional competencies of faculty members across the nation through impactful and high quality training. It is my honor and privilege to introduce first esteemed resource person for the today's session, Mr. Vijay Kumar Yadav sir. Sir is working as a manager, mechanical maintenance in Krishak Bharti Cooperative Limited, a Government of India enterprises. Mr. Yadav is an accomplished mechanical engineering professional with a BTech degree in mechanical engineering in 2008 and over 16 years of experience and industrial experience. He has been associated with Fertilizer Limited since 2012, where he presently serves as manager mechanical maintenance. He oversees the preventive, predictive, and breakdown maintenance of major utility plant equipments.
Yeah,
Among
Krishna.
his notable contribution and inspiring work in energy conservation achieved through the successful implementation of energy efficient system for air and boiler feed operations. We are privileged to have with us, sir. Thank you for sharing your expertise.
महसूस
Now we are requesting our distinguished eminent guest, Mr. Vijay Kumar Yadav, sir, to please allow us to start the session, sir. Sir, you are humbly invited, sir. Please start the session.
Good evening, all of you. Is my voice is clear?
Sir, it is clear, sir.
Yeah, yeah. I am very thankful to management of United College to giving us opportunity to share our experience in such platform. I am Bijan Kumar Yadav, working in KFL as a mechanical engineer. We are responsible for day-to-day maintenance in utility plant. Now, without wasting a time, we are giving our presentation. Our topic is, sir, hello. 1 minute, sir. Now, our topic is importance of utility plant in the fertilizer industry. As you all know about the utility plant, utility plant is the crucial for the fertilizer industry because it provides essential service like power, steam, water treatment, and all the things which is required for to run the.
Pardon, sir. Sir, your PPT is not visible. Kindly share your PPT.
Yeah, I am sharing to you.
Not is visible.
Is it visual?
Your voice is also audible and the PPT is also visible.
Voice is not clear?
Voice is audible, sir.
Okay.
Clear, sir.
Okay. Now, first we all introduce our fertilizer industry. KFL Sanjapur is the gas-based fertilizer plant comprising of ammonia plant and urea steam. Our main product is the urea, which is based on the ammonia and carbon dioxide. The plant daily production is near about 3,000 metric ton per day. We are working with a utility plant. Utility plant is not important for a fertilizer industry only, but it is also important for all the small industry. like a steam, power, water. If we left the steam, then power, water, air is necessary for all the plants. Some industry can set up the power plant itself, and some small industry can import import the power. If he is not in this situation, that he can set up the plant. It ensures the efficient operation of machinery and help manage environment conditions by supplying the reliable power, steam for process, and water for production. Water utilization of water in many types. In fertilizer industry, water treated water is utilized, such as for the production of steam. We cannot use the direct raw water due to the its impurity, because large number of minerals are available in the that water. So we just demineralize the raw water and use DM water. If we say about the power, since the fertilizer power requires the constant load, any fluctuation in the power will lead to sudden tripping of the plant and huge losses for the company. Hence, we cannot procure the power from outside agency. And the power plant is mandatory to run a industry like a fertilizer plant. We cannot depend on the outside agency or the government, UP governments, central government. We cannot. Steam generation, steam is also required for the plant. It is required to run the steam turbine. It is required to heating the vessels. And water management, we can give the brief introduction in the letter. If you see that what type of utility is required to jump for the fertilizer industry. The offsite plant is meant to supply the utility required for the production of ammonia and urea in this ammonia-urea complex. Utility also named as a offsite plant. The commonly known utility required by any of the industry are power, water, air, and steam. This is the main utility. But behind this, much more utility facility are also available in the fertilizer industry. These are required. This is mandatory. Some of listed are there. Power generation, steam generation, raw water, DM water. DM water means demineralized water. Fire water, fire pump house, cooling water, instrument air, and utility air, effluent treatment plant, emergency diesel generator set, ammonia storage, naphtha storage. If you are using the naphtha as a fuel, then a naphtha storage tank is mandatory. But nowadays, most of the plant are using the NG, natural gas, as a fuel due to its higher calorific value, and nitrogen storage. These are the main utility which is most compulsory to run the fertilizer plant. As we explained earlier, that power generation, power is the very crucial. Steam generation, steam is also very important. Such like that, all the below mentioned utilities are important for a fertilizer plant. We are here explaining here about the fertilizer plant, but these are also required in every industry. Some of them may be imported, or some of them may be inside the plant. And now we can explain one by one all the raw water. Raw water is the water which is available in that earth, either in the underground water or river or a ponds. It can be different. Many industry are utilizing the river water as raw water. Many industry are utilizing the raw water from a storage pond. Since we have a lot of underground water, so we are utilizing here the raw water, underground water as a raw water. For that purpose, a lot of borewells pump or installed are there. You need to install the borewell pumps, which pump the underground water up to desired height as a required flow. For example, the KFL, there are total 11 number of borewells are there. It doesn't mean all the pumps are operating. Some pumps are standby and some pumps are in operating condition as per a plant requirement. If it be required, suppose we require the only 240 meter cube per hour water, then we can use one pump only. If the plant demand increase, then another pump will be in running condition automatically due to automation. Same is right here. Water is taken from the borewells as per requirement by operating a number of borewell pumps. We have total number of 11 number of borewells. Out of them, one is reserved for township drinking water. These are the drinking water for the drinking water purpose. One pump is reserved because our township is nearby the plant. Hence, we are supplying the drinking water to our township from the plants. Water is transferred through the pipelines which are laid down, either it is underground or above the ground level as per our availability. Since raw water is has the number of impurity inside the raw water, minerals also available in the raw water which cannot be directly used to run the steam boiler. Why? Because these minerals available in the raw water create a layer inside the tube of boiler. Our plant have a water tube boilers. It means water inside the tubes and heat source outside the tubes. If we use the raw water as a boiler feed, then minerals available in the raw water, it deposits on the tube surface. It means scaling form. Or these scaling will reduce the efficiency. Why? Because heat transfer will not be proper. If heat transfer will not proper, then huge amount of gas are required. So efficiency of boiler is automatically reduced. To make the available raw water for the steam generation, utility plant also have a DM plant. DM plant means dim light water plant. So raw water contain a number of impurity and cannot be used as for purpose of making steam. It is therefore necessary to remove all the impurity before making it suitable for the use of boiler. The purpose of plant is to remove the minerals from the raw water and make it perfect in the boiler. The water thus produced is called the dim light water and plant as DM plant. As per the plant requirement, how much water is required, how much steam is you are generating, depending on the power requirement of water, the capacity of DM plant decided. Our requirement is large, hence 3 trains of 234 meter cube per hour capacity provided
ऊपर डाल दे
here.
बस सोनल के घरे हम पचे आई ला गए
234
आप लोगों
meter cube
सोनल
capacity is the requirement for our
क्या बनाओगी?
boiler system,
हाँ,
but at the plant running condition, most of the water coming back
मनी
due to
बचे क्या बनाओ?
condensation. In the ammonia plant and urea plants,
ये कौन सिखाया है तुमको?
high pressure temperature gases, high temperature and pressure fluids are passing through a pipeline. It means there is condensate there. And all these condensate we cannot waste. Wastage of condensate is not permissible. All the condensate, which may be a process condensate, it may be a turbine condensate, coming back to the DM plant. It reduces our water consumption as well. So DM water is very mandatory for the steam boiler. DM water is usually used for only for making steam, and for other purpose we are using the raw water directly for the purpose of the heat exchanger, cooling. Cooling another fluid. We are using the raw water directly with the help of cooling tower. We cannot waste the water. We have a large number of cooling tower cells in the plants to cool down the water to desired level. We can explain later. So the main purpose of DM plant is to make water suitable for the use of boiler. Why? Because minerals present in this boiler, raw water, form a scaling inside the boiler tube and leads to decrease the efficiency of boiler. It is not only scaling formation, but it is also corrosion and erosion inside the tube due to high temperature. Minerals attack on the tubes and get corroded. Violet tubes, corrosion, erosion means damage of tubes. Boiler tube damages is not good for the health of the boiler, because if you see the boiler, this is very compact in design. Boiler is very compact in design. To identify the tube leakage is not an easy task, and to replace the tube is also not an easy task, because very sophisticated technology are required for welding boiler tubes. So we avoid, all the industry avoid to use raw water as a boiler feed. Hence, DM plant is mandatory to run a boiler. DM water thus produced is having the following quality: pH 6.8 to 7.2, conductivity less than 2 micron, silicon oxide 0.015 ppm. We can explain, which is written here. The DM water treatment plant consisting of provision for treating raw water received from the tube well and return condensate from ammonia and urea plants for feed water, boiler feed water. The raw water, along with treated turbine condensate of ammonia urea plant and treated process condensate of ammonia plant, is treated in 3 steam of DM section, each steam of capacity 234 meter cube per hour. This is our setup plant for DM water. All the vessels have its own property. Demineralization of raw water is not a easy task. How many number of processes are required? During the demineralization process, actually we remove the cations and anions present in the DM water. For the removal of cations, a separate unit is there. For the removal of anions, a separate unit is there. Also, we have a degasser tower, to remove the CO2 present in the raw water. Since we are the mechanical maintenance engineer, hence health checkup for the equipment is our responsibility. You are saying in this photograph that these are the tanks. If you say that the bottom of the tank has been corroded, due to corrosion, it gets damages at the bottom side. In this process, number of chemicals are utilized there. These chemicals are not good for the health of a metallic surface. Since all the vessels are the metallic, you can say that a mild steel. Chemicals attack on the surface and corrode the tank. To avoid such type of failure, internal surface of the tank is either coated or rubber lined. Here we are using all the vessel which have the inside rubber line. This rubber is the natural rubber, pure gum natural rubber, which has the very strong corrosion resistance property. If any defect is formed in these rubber, then fluid inside it will spread out and get touching with the surface. So the periodic inspection is very mandatory. Otherwise, this situation will happen again and again. This tank has been collapsed very badly. Now next one is the steam generation. Steam is also required to run the gas turbine. In the plant, there is a number of gas turbines are there. Some of driving the pumps, some of driving the compressor, some of driving the generator for generating the electricity. But here is only we are using the turbine and pump. Steam turbine as a drive for the pump. To fulfill the steam requirement inside the plant, we have the four number of boiler. Actually, the common boiler is 2, and 2 is the heat recovery steam generator, which is also known as a boiler. As per the plant requirement, it can be differ in other industry how much steam required to run the plant. It depends on capacity of turbines. In our plants, actually 420 ton per hour steam is required to run the plant. Total 420. But out of which 280 ton per hour is produced with NS3 plant, मतलब ammonia plant. Ammonia plant itself produce steam. As and when it's coming on a full load. During the startup period, no production of the steam in the ammonia plant, and all the steams were transferred to ammonia plant from the utility section. As and when plants is running in a full condition, then total 280 ton per hour production coming from the ammonia plant, which is sufficient to run the turbines at ammonia section. We required only 130 to 140 ton per hour steam to run the equipments in the offsite plant and in a urea plant. To meet the such requirement, we have a service boiler, 2 number service boiler. Full detailed description is here. Capacity 100 ton per hour each. Pressure, generating pressure 115 kg per cm square. Temperature 515 degree Celsius. And we also have the 2 number of HRSG. We explained in the letter. HRSG is actually direct coupled to the gas turbine on utilizing the exhaust of the gas turbine. That's why it is called HRSG, heat recovery steam generator. Capacity for boiler and HRSG are same. This is about the boilers photographs. All the steams inside transferred to the other plant through a pipeline. Since the pressure and temperature is very high, 515 degree Celsius temperature at a 115 kg per cm square, it is very important to select a material for piping carefully. As per IVR regulation, welding joints of the pipe should be crack free, pin hole free. Hence, maintenance of boiler is very difficult. Suppose there is a leakage in a pipeline. Welding is not that pipeline is not a easy task. It required at least 24 hours for all the procedure. Preheat, heat, post heat, stress relieving because of the special metallurgy. Actually, all the high pressure pipeline, superheated steam pipeline, material of that is P22. P22 is the alloy steel. Hence, during the maintenance period, during the shutdown period, while you changing the pipeline or changing the any valve, you can aware the procedure of welding. Welding procedure is very important. Maintenance, if you say the maintenance of boiler area, boiler feed pump. Boiler feed pump are utilized to feed the water inside the boiler. Since we require the steam at 117 kg per cm square, hence the boiling feed water is also more than the required steam. Our boiler feed water from develop pressure 140 kg per cm square to 220 kg per cm square. Different type of pump are there. As per the plant requirement, if we need a 220 meter cube per hour flow, and we run this one, and if we required 110 meter cube per hour, then we run another pump. Due to the scenario of the energy consumption, we should also aware that the energy utilized for running the pump. That's why, as per the requirement, we run the suitable pump. Pump is the centrifugal pump of 17 stage. One pump is 11 stage as per the capacity. All of you know about the stages of the pump, because to develop the higher pressure, to develop the higher head, number of stages increased. This is the line diagram for the surface boiler. Here is the boiler feed pump, enters through the economizer, sent to boiler drum, and then furnace. Here is the temperature is 950 degrees Celsius, and goes to superheater. Furnace, boiler to superheater, boiler drum to superheater, and then superheated steam to the plant. Exhaust gases from the furnace is go to chimney through the economizer, air preheater. When air is enters through the air preheater, flue gases heated the air, hence efficiency of boiler increase. These are some equipments where you need to focus on this. Tube leakage. To avoid the tube leakage, periodic inspection is necessary. Inspection means to check the thickness, to check any spots on the tubes. If you have any doubt, you can do the DP test, dry penetrating test, because some of the cracks, some of the pinholes is not visible. Second one is insulation. Boiler furnace, where the combustion is taking place, is duly insulated inside. This is due to avoid the heat transfer. To avoid the heat transfer from the inner side to outer side. And the inspection of the insulation is very, very necessary. Otherwise, proper efficiency we cannot get. Valves. Since all the pipelines From the one point to another point, we are supplying the steam. Valve are installed are there. Maintenance of valves is also required. PSB. All the boilers and boiler pipelines. There are a number of PSB of different set points. For a high pressure steam, whenever the pressure inside the pipelines are 125, 115, 125 kg per cm square, then there is a set point of PSB. It is due to when the suppose that pressure of the pipeline is increased due to some mishappening in the process and reach beyond the limit of piping strength, and piping will collapse. To avoid these failure, all the pipeline are fitted the PSBs. Boiler itself fitted with the PSB. Suppose that our pressure inside the pipeline is 124 kg per cm square, and due to some mishappening, it goes 135. So the PSB, whose set point is the 134 kg per cm square, will pop up and release the extra pressure to the either to the atmosphere, either to the other means. So the maintenance of PSB inspection, testing of PSB is very mandatory. Piping, I explained. Feed pump, we say that our feed pump is 11 stage centrifugal pump. Periodic maintenance to avoid any failure during the running condition. All the engineer ensure for its reliable and sustainable operation by changing its oil, by changing its bearings, it won't get damaged, and other things. Now, gas turbine. I explained earlier that our plant is running on a continuous and constant load. We cannot depend on the outer agency to supply the power. Hence, our own setup power plant is there. We have the two numbers of gas turbine of 22.4 megawatt capacity each. Actually, our plant requirement is only 16 to 17 megawatt load. But you know that the turbines, when gets older, it is not giving the 100% efficiency. Out of these two, only one gas turbine is running and another is the standby. one gas turbine is developing the power sufficiently to catch up our client load. We are generating the power through the gas turbine, and natural gas is used as its fuel. All of you know the working principle of gas turbine. Gas turbine is working on the Brayton cycle. And here the air is sucked from the atmosphere and compressed in the compressor. Stage is 17 stage, and developing the pressure only 7.4 kg to 8 kg per cm square. But the flow is huge. Its capacity to 240,000 CFM. The air is sucked from the atmosphere and compressed in the compressor. It then sent to combustion chamber. Combustion chamber, where the fuel mixed with the air and combustion takes place. Fuel may be natural gas, diesel, naphtha, as per designer. Actually, our the gas turbine initially when commissioned is running from naphtha, but due to unavailability, due to its low calorific value, we replace system from naphtha to natural gas. So the high temperature gases at high pressure then expanded at the turbine nozzle and make the turbine to rotate by utilizing the heat combustion. As and when sustainable speed gas turbine, our driving system decluttered the turbine shaft, and now turbine rotate with the help of combustion gas. This is the gas turbine plant. Here you seen that this is the inlet air section. Inlet air is the atmospheric air which contain number of impurity, dust, small particle, which is not good for the compressor and turbine, because particle enters along with the air, impact on the turbine compressor blade and deposit. Hence, suction air filtration system is required here. This system filter the air and remove the dust particle up to 0.2 micron, and then air enter compressor to combustion chamber, where combustion take place and expand on the turbine. And exhaust gases out from there. We earlier explained that we have the two number of HRHE. This is the HRSG, heat recovery steam generator. The gas, exhaust gas, after expansion with huge volume and temperature around 550 degrees Celsius cannot be wasted. To utilize, machine is installed with the heat recovery steam generation. For steam generation, approx 950 degrees Celsius is required, and here is the 550 degrees Celsius. To achieve this, an extra supplementary firing system is also available. So this is the HRNG, just like a boiler, and generate steam. For the plant requirement, since the one gas turbine is always in running condition and generate the steam approx 80 ton per hour, and our plant requirement is 130 ton per hour. For the rest of the 50 ton per hour, another boiler is used. One turbine is running, one turbine is standby. We are saying the word standby. Standby is nothing but standby means a machine is ready to start. One machine is running condition and another is standby condition, means it is ready to start. When there is a fault in the running equipments, another will automatically start. Since the process plant, if there is a fluctuation in the electricity, then our whole the plant will get tripped. This is the breakdown cycle, all of you know. Maintenance of the gas turbine is very important and very difficult task, because all the spare parts continuously contact with the high temperature, and centrifugal force, centrifugal action is there. So the manufacturer decide the periodic interval of the for maintenance. Some of them is there. First is boroscopic inspection. This is not required, but it is need-based inspection. If you want to inspect a turbine or compressor blades condition, then with the help of boroscopic, we inspect turbine internals, compressor internals at the time of standby condition. This is not in running condition. Second one is compressor water washing. Since we are using the atmospheric air, but after filtration, some of the particle, smart particle, and due to the some problem in the filtration system, some particle get deposited on the turbine wheels. To remove the following, compressor water washing required. Next one is combustion inspection. Combustion inspection. Combustion, as a name, combustion inspection is required those part who is related to the combustion only. So manufacturer recommended to do the combustion inspection at every 8,000 to 10,000 running hour. When completed its 8,000 or 10,000 running hour, you need to inspect its combustion area. And if your machine completed 16,000 to 20,000 hour running hour, this is not a standby, this is running hour. Hot gas path inspection. Hot gas path inspection include the combustion inspection and the area where the hot gas passes. Means it is from the combustion area to the exhaust section. All the parts should be inspected very carefully because reliability of the gas turbine is the must, as all the plants are depend on its power. Major overall. After completion of 30,000 or 32,000 hour, major overhauling is scheduled. Major overhauling means combustion inspection, hot gas path inspection, and other every parts. Means flange to flange, one flange to another flange of the gas turbine, all the parts should be inspected. During the major inspection, machine dismantled totally. Every part taken out, inspected, replaced, whatever required. This is our air filtration system. This is the cylindrical type filter, air filter. Approx 400 filters are installed in a gas turbine to capture the requirement of 240,000 CFM. Replacement of all these filters are depend on the DP. DP means the pressure outside the filter and after filtration how much pressure we get. To run the turbine at proper DP is very much because all the performance of the gas turbine are depend on its differential pressure. Generally, our recommendation and OEM recommendation also to run the gas turbine below the 75 mmWc, millimeter per column. Above these, you should need to replace the filter, clean the filter to achieve the DP below the 75 mmWc. As and when we clean the filter and not get succeeded to achieve the DP below the 75 mmWc, then replace all the filter with new one. This is a symmetric view of gas turbine. Auxiliary, this is the auxiliary gearbox, and here is the main gearbox. This is the drive. This is the combustion inspection. We explain hot gas path inspection, major inspection. This is the condition of the turbine at the time of major overhauling. It is compulsory to check every clearances before dismantling the turbine, so we can decide what part are required to replace or not. Here you can see that this is the turbine, two-stage gas turbine. First one stage is this, second one is this. If you see that there is the dent in the buckets of the turbine, it means these buckets have completed their service life and need to replace with new one. Also, we check the clearances between these buckets, and here is that called the shrouds. So the care should be taken during the maintenance of the gas turbine. Among all the three inspection, only combustion inspection can be carried out itself. Otherwise, for the major inspection and hot gas path inspection, also external agency is required and expert manpower is required. Because this is a very huge machine and its rotor weight is about 15 metric ton. Only rotor weights. Rotor means this is the compressor and turbine buckets and its shaft weight. This is the rotor. Its weight is approx 15 ton. When we put the rotor outside the turbine, all the blades, turbine blades, compressor blades, bearings area surface, coupling area surface, all the rotor thoroughly checked, and it is due to its reliable and sustainable operation. Factor affecting the performance of gas turbine. As we say that ambient temperature and inlet pressure loss is very important for the efficiency of the gas turbine. Here in the thumb rule, if the 4-inch water column inlet drop produce 1.42% power output loss. It means 4-inch means if we run our machine at 100 mmWc water column, then bed power output get reduced by 1.42%. Heat rate will also increase. heat rate is nothing, but it is the ratio of energy consumption to the power. How much energy consumption will get increased will decide the heat rate. Hence, differential pressure of the suction air, to control the differential pressure of the suction air is very important to make the machine efficient. This is the some parts of the gas turbine. This is the parts of the combustion area and called the fuel nozzle. Here you can see that there is some carbon deposition. If we run the machine with in this condition, then automatically there is no perfect fuel injection, perfect combustion. So these parts replaced. This is the combustion liner. Here is the combustion. Inside this combustion takes place. At the time of combustion, the temperature of this area is about 70 degrees Celsius. So the metallurgy of this parts is very important. All the parts which is in contact in the high temperature is the nickel and cobalt waste. High nickel and high cobalt, approximately 39% cobalt and nickel. Special name of the metallurgy GT111 hashtags. Very special material is there. If we get found any defect in this parts, we cannot repair in-house. Means KFL or other industry will also not have any service like that to repair these parts of special material. This is the inspection of each and every parts. This is DP test, dry penetrating test, from which we found defect, any cracks in this portion. This is the nozzle, turbine nozzle. So after the gas turbine, power generation, now we will discuss about the cooling tower. Cooling tower is important to run the plant because number of heat exchanger are there. During the process, we required to cool down any product at a certain temperature. So the easily available is the source for easily and cheap available is the water. Water passes through the heat exchanger. Either heat exchanger is either tube, cell and tube types, fill type. One side is the water, and another side is hot fluid. Energy transfer formation is there, and the water get heated. This heated water can not be utilized anymore, but we cannot waste the water. To make the available this heated water for the use of the plant, system passes through the cooling tower. Cooling tower, where it get cooled down up to certain temperature and available to use for again use. In the KFL, the plant is divided into three areas: ammonia plant, oxide plant, urea plant. In the different section in the some process, some of the heat is generated, which is to be removed before the product is sent for the other process. Water is used as a cooling media, as it is cheapest media available abundance. The purpose of cooling tower is cool down the return water, thus heated in different plant. In the process of cooling, the fluid is different in different plant. The cooling water temperature rises by about 8 to 10 degrees Celsius. To bring the temperature back to original temperature, a cooling tower is required because we cannot waste the water. There is different type of cooling tower available in the market. Manufacturer provide the cooling tower which is different model. Suppose some of them the induced draft tower. Some plant have a post draft cooling tower. Some of them cross flow, some of them counter flow. There are different type of cooling tower is there. Cooling tower, after cooling, water cooling and transferred to the plant through the pumps. Cooling you are seeing, all of you seeing this image clearly.
Yes, sir.
Okay. Now you see that the induced draft counter flow water fill tower. This is the different name. This is the water fill tower because here is the no fill zone area is there. This is only water fill tower. Hot water enters the tower and spray. Air enters from the side of the tower, and here is the induced draft fan. This fan induces the heat to the atmosphere. Second one is the fill. Since here is the fill area, fill is nothing but this area increase the surface area of the water droplets. When one drop contact with the fill zone area, it is splayed out. And the result of this, surface area increase. This surface area increase lead to more and more heat transfer. It is simple phenomenon. Now next one is induced draft double flow cross flow tower. Double flow means there is hot water distribution in both sides of the induced draft fan. Water enters at the top of the cooling tower and circulate passing by fill zone area. Here is the fill zone area where the droplets spread out and increase the surface area. Here is the air contact with the hot water, and then passes through the, here is the called the drift elevator. This area is called the drift elevator. Drift elevator, purpose of drift elevator is to reduce the drift loss. Drift loss means to avoid the entry of water particle along with the vapors, water vapors. So this is the different type of cooling tower, in which the most commonly used cooling tower is the induced draft double flow frost tower, and this is in the KFL also. This is the cooling tower circuit: ammonia cooling tower, urea cooling tower. Since our requirement is huge, we have a 12 number of cells of cooling tower is there. Our requirement is about 40,000 meter cube per hour. Such a huge quantity cannot be cooled by the single tower, because such type of, there is a wide diameter of fan required. So we divided all the towers in the 12 section. Some of used for ammonia and some are used for urea. This is the systematic diagram. This is the ammonia cooling tower range 20,000 meter cube per hour. Urea cooling tower range 18,000. Number of cells 5. Number of cells 7. This is the cooling tower. Initially, cooling tower made up by the wooden structure. All timber material is used to commission the erection the cooling tower. This timber is not a simple timber, but it is the imported from USA, New Zealand, American pie, from the outside of the country. And now, due to limited resources of wood, timber, all the plant replaced the timber with the pulveted FRP material. This is the inside view of cooling tower. Cooling tower performance depend on these two factor: range and approach. Range is the difference between the cold water temperature and cold water temperature. We try to cool down the water at its bed world temperature. Now the instrument air compressor. Instrument air compressor is nothing. It is the compressed. It is used for to compress the air. But since the instrument air, compressed air have a moisture inside it, which is not suitable to operate a valve, control valve. Our plant have a number of control of valve there, because in a heated area, man cannot be operate a valve, and due to the automation, all the valves are control valves are operated through the air to open, air to close. To remove the moisture from the air, compressed air, there is a separate plant of dryer is installed, and dry compressed air have the following specification: dew point minus 40 degrees Celsius, pressure 7 kg Celsius. So the instrument air is very also important. So the effluent treatment plant is also there, because we cannot discharge the effluent directly to the outside the plant due to the CPVC norms. For the treatment of effluent treatment plant is also important. Fire water and fire water pump. Fire water inside the plant is very compulsory to handle any fire hazard. For this, every plant have a fire pump house. The purpose of fire pump house is to maintain the required pressure inside the fire header pipeline. These pumps, all the plants have the fire pump house. You can also say the fire pump house inside the malls, hospitals, etc. During the normal course, there should not be any water consumption from the network. Header is kept pressure up to 8 kg cm square. Header pressure always kept 8 kg per cm square. There is number of pumps in the fire pump house. When B get reduce in the pressure, then one pump is automatically start and maintain the pressure up to 8 kg cm square. If suddenly pressure goes down and reach 6 kg per cm square, then all the pumps will start to maintain the header pressure. To catch the requirement in case of fire hazard, when there is no electricity, two emergency diesel engine pumps, driven pumps also available, and it is recommended. Ammonia storage. Ammonia storage is the tank which stores the ammonia inside it. Our plant also produce ammonia, excess amount of ammonia. If we required 1900 ton ammonia for the production urea, and we produce 2000 metric ton of ammonia, then this excess ammonia, 100 metric ton ammonia, now stored in the ammonia storage tank. Ammonia storage tank is not a simple tank, because ammonia is very dangerous. It vaporizes vaporize at minus 32 degrees Celsius, and our storage temperature is minus 33 degrees Celsius. We store all the ammonia inside the tank at a minus 33 degrees Celsius temperature, because if the temperature increase and get only minus 32 degrees Celsius, all the ammonia will vaporize here. This tank is not a simple tank. It is double tank. double wall tank, and there is the vacuum between the first wall and second wall of the tank, and insulated at the outside. So this is also important tank for the utility section. We also have a facility to sell the liquid ammonia to the market, and this is very dangerous process. Or utility plant or offsite plant also have the emergency generator set in case we have not we have found any fault in the power plant, then the emergency diesel generator set will help to run the emergency equipments, such as for the gas turbine. If suddenly stop, then blue wall system is very necessary to supply the blue wall to the turbine. And now we have completed all the equipments of utility plant. Thank you.
Any question? Thank you, sir, for the wonderful session.
Thank you. Thank you.
Any question from the participant side? You are most welcome. Thank you, Brijen Kumar Yadav, sir, for the enlightening and the knowledgeful session. We learn about a lot regarding the ammonia generation, regarding the liquid nitrogen generation, and regarding various equipments used in power plants like cooling towers, condensers, etc. And it's working because it's give us a great pleasure to deal the theoretical knowledge with other practical skills. Thank you, sir, for the time you have given to us and for this enlightening knowledge which you has given to us.
Thank you.
Thank you for accepting our invitation, sir. We are looking forward such in future endeavor also, sir. Thank you very much, sir.
Thank you. Thank you.
Good night, sir.
Good night.
Good evening, Manoj, sir. Please switch on your camera.
Hello.
Yes, good evening, sir.
Good evening. Good evening. Okay.
Please switch on your camera, sir.
Okay, so I'm talking to Dr.
Gaurav Verma, sir. Your
Gaurav.
host, sir. Yes, sir. Your host, sir.
Okay. So Gaurav, I have joined and my PPT is visible to you or not?
No, sir. Right now it is not visible.
Okay.
All the participants are requested to be seated. There is a technical glitch. Sir is joining within a few minutes.
राकेश जी, पीपीटी शेयर करने की कोशिश कर रहा हूँ, कुछ देखता हूँ मैं। हाँ, hello, doctor. Hello.
Yes, sir. Yes, sir. You are audible, sir. Please switch on your camera.
PPT is, I'm unable to know. PPT is not being visible by. I'm sharing my PPT, but it is. Huh? Okay.
Sir, now the screen is sharing. Yes, sir.
Okay.
You can open your PPT, sir.
Okay. Wait.
ਰੋਟੀ ਕਾਹਦੇ ਵਾਲੀ ਬਣਾਈ ਉੱਥੇ ਹੀ ਚਲ ਜਾਂਦੇ ਆ ਮਗਲਾ ਤੋਂ ਵਧੀਆ ਪੀਤਾ ਹੈ ਨਾ ਚਾਹ ਉਹ ਖੜੀ ਲੱਗੀ ਉਹਦੇ ਨਾਲ ਬਾਬਾ 1.5 ਘੰਟਾ ਕੱਢ ਕੇ ਉਹ ਲੱਗਦੀ ਹੁੰਦੀ
Mhm. शायद होगा ना।
Sir, now the PPT is visible.
हाँ ना, PPT is visible. Okay,
Yes, sir.
okay, thank you. Okay. Okay.
Can I start, sir?
Just 1 minute. Just 1 minute. Okay. नहीं, this PPT, okay, just wait. नहीं, ये वाली PPT नहीं थी. हाँ, Dr. Saab, PPT is now visible to you or not?
Yes, sir. Yes, sir. PPT is visible.
Which PPT is visible? Advanced
Advanced
manufacturing.
manufacturing for Industry 4.0, sir.
Okay, thank you.
Okay,
You can
full
start.
screen. Full.
Okay. Now you can start.
Okay, sir. Moving ahead, it's my distinct honor to introduce the second eminent resource person for the day, Dr. Manoj Kumar Gupta, sir. I request, sir, please switch on your camera. Sir is Associate Professor in Department of Mechanical Engineering, MUT, Gorakhpur. Sir, it's my profound honor to introduce our esteemed resource person for today's session. Dr. Manoj Kumar Gupta, sir, is an accomplished academician, exceptional researcher, and one of the most distinguished figures in the contemporary field of mechanical engineering. Dr. Gupta is currently serving as an assistant professor, grade 1 in the Department of Mechanical Engineering, MUT, Gorakhpur. Prior to it, he is also worked as an assistant professor in the Department of Mechanical Engineering, MNIT, Allahabad. A scholar per excellence, Dr. Gupta has consistently listed among the world's top 2 scientists, a prestigious recognition he has received every year from 2022 to present. Congratulations, sir. The distinction highlights his global impact and outstanding research contribution. Academically, Dr. Gupta holds a PhD degree in design from MIT Allahabad, MTech in Computer Integrated Manufacturing from MUT Gorakhpur, and a BTech in Mechanical Engineering from Integral Institute of Technology, Lucknow. His scholarly output is truly remarkable. He has been author over 150 publications, which includes 103 research paper in international journals, 89 index in SCI Scopus, 35 conference papers, and including 27 international conferences, 1 book and 6 book chapters. He also granted 1 granted patent and 2 published patents, demonstrating his innovative spirit and contribution to technology advancement. Dr. Gupta research influence is evident from its 4,500 plus citation, H index of 35, and I-10 index of 69. In addition to his research accomplishment, he has been successfully completed 3 research projects, supervised 8 PhD scholar completed, and 3 ongoing under his supervision, 25 Tech dissertations, and 1 going on, 20 BTech projects. His academic commitment is further reflected in his credit points exceeding 300 plus, for surpassing the requirement for senior academic position. With such extraordinary academic footprint, research excellence, and dedicated leadership, Dr. Manoj Kumar Gupta sir stands as an inspiration for educators, researchers, and students alike. We are truly privileged to have with us as a distinguished resource person of this Atal ASAT Faculty Development Program. Sir, we wholeheartedly welcome you and look forward to benefiting from your rich expertise. Thank you. Now, sir, I welcome you for start the session, sir.
Hello, Dr. Rohit. Hello.
Sir, your PPT is visible as well as your voice also audible. You can start the
Okay.
session, sir.
So can I start my lecture?
Yes, sir. Yes, sir. You can, sir.
Okay, so thank you so much, Dr. Rohit, for wonderful introduction of myself. And I am very thankful for inviting me for the expert lecture for the program Advanced Manufacturing for the Industry 4.0 in integrating additive technology and sustainable practices, organized by the United College of Engineering and Research, Prayagraj. And as far as I am aware, this college is rapidly improving its quality, as known is for the excellent teaching and research in not only Prayagraj but UP also. So, and thank you everyone, for every member of the committee for inviting me
Thank
for
you,
the
sir.
lecture.
Thank you, sir.
So let me start, and I will also thankful that United Engineering College is selected a very wonderful topic, that is the advanced manufacturing for the industry 4.0, integrating additive technology and the sustainable practice. This is a wonderful topic for your participants, and I'm sure that participants will be getting to the benefited by attending this FDP, because this topic is a very interesting and going to be very useful for all the participants. So my topic is, as I have selected, nanocellulose-based bio-nanocomposite and additive manufacturing, a sustainable route to Industry 4.0. So before starting my lecture, I would like to suggest to the participants, if they have any queries during my lecture, please ask and don't wait for the end of my lecture. They can discuss during my lecture if they have any doubt. Don't wait for the end of my lecture. And I want to make this session interactive, so you can discuss during my lecture. I have no problem. And so let us start. As you know, there is now we are all the industries is looking for has trying to become industry 4.0 and the 5.0. Maybe some participants may not aware of what is the industry 4.0 and its aspects. Why we're talking, why FDP is being organized on the industry 4.0. So let us talk a little about what is the industry 4.0. If you talk about the industry 4.0 is the fourth industrial revolution. Now industry 5.0 in the same way, that is the fifth industrial revolution. And this industrial revolution, industry 4.0, is the transformation of the manufacturing and industrial system through the intelligence digital technologies. Industry 4.0 is also known as the digital industry also. In other ways, you can say industry 4.0 is the smart manufacturing. And if you talk about the aspect of the industry 4.0, like the cyber physical system, Internet of Things, IoT. IoT is very popular in our industries. And a lot of research is going in the area of the IoTs for the industry 4.0. One more thing, there is a lot of scope of the research in the area of the IoT for the industry 4.0. Big data analytics, artificial intelligence, and the machine learning. Artificial intelligence and the machine learning is not limited to any discipline, but it is the popular in the all discipline, on the all the program in the all area of the research. Either you are the working in the area of the mechanical, or you are the being background of the electrical, electronics, computers. AI and the machine learning are being used nowadays everywhere. Additive manufacturing, 3D printing, a wonderful technology that is the opposite of the machining and Additive manufacturing has been very popular, not only in the area of the composite materials. If you talk about the house construction of the house in the few days, additive manufacturing has been very popular. And one more thing, additive manufacturing not limited only to the small products, but it's had extended its application to the very high and the large products. Robotics and automation, cloud computing, smart materials and advanced manufacturing, sustainability and circular manufacturing. So these are some aspects on which Industry 4.0 based on. My topic is based, as I say, nanocellulose and its bio-nanocomposites. A route toward the sustainability of the Industry 4.0. So now there is a big question: how nanocellulose and its bio-nanocomposite is aligned with the sustainability mandate of the Industry 4.0. Industry 4.0 emphasizes on the green manufacturing. And if you are talking about the green manufacturing, it means what? Low carbon material, low impact to the environment. And if you are using the nanocellulose and its bio-nanocomposites, so you should be aware these materials are the completely renewable, biodegradable, and the carbon neutral. And that's why nanocomposites, nanocellulose and its bio-nanocomposites is the base and the future of the green manufacturing for the Industry 4.0. These are the energy efficient production and waste. One more thing, waste to the wealth transformation. The last one is the waste to the wealth transformation, means the nanocellulose are extracted from the waste biomass. That's why here it is written waste to the wealth transformation. Materials for the smart, lightweight, high performance manufacturing. Industry 4.0 demands material that should be the lightweight for the mobility, easy transport, and for the electronics applications. Strong and multifunctional. Nanocellulose is advanced nanoparticles which have capability to provide multifunctional characteristics, compatible with the robotics and the automated processing. Nanocellulose has completely compatible with the robotics and automated processing. Supports digital manufacturing and automation. Nanocellulose good fits directly into the Industry 4.0. Automated process control. Nanocellulose gel and suspensions are compatible with the robotic handlings. Rheology can be tuned for the automated mixing, molding, and extrusion. Predictive molding and the digital twins. Smart supply chain integration. Rakesh, what happened? Okay. Application that support the Industry 4.0 goals like the smart packaging, biodegradable packaging with the moisture and the spoilage indicators, IoT enabled nanocellulose levels. Nowadays, everything is being smart. Now, what is the smart packaging? As I said, nanocellulose are the multifunctional, and that can be used for the smart packaging, automotive and the aerospace. What should be the characteristics for the automotive and the aerospace, like the lightweight interior panels, structural parts, and the foams? And this can be easily produced by using the nanocellulose and its bio-nanocomposites. Improved fuel efficiency and the sustainability compliance. If you talk about this nanoparticles. These are the very light in weight, having the very low density, and that can improve the improved fuel efficiency. Electronics and their wearables, biomedical industries, and construction and infrastructures. So these are the applications where nanocellulose can be used. Let us talk about the nanocellulose. So nanocellulose is the nothing but nanocellulose is the nano part of the cellulose. Majority of the you already aware about the cellulose. Cellulose is the renewable neutral polymer that has the formula C6H10NO5. And it is also very important about know about the cellulose. Cellulose is the most abundant biosource in nature. Cellulose is the one of the most abundant biosource in nature, and production of the cellulose worldwide is around 1.5 into 10 to the power 12 ton per year. You must be surprised to know the worldwide production of the cellulose. If you see this quantity, that is the 1.5 into 10 to the power 12 tons per year. That's why it is the one of the most abundant bioresource. And cellulose are the non-toxic, biodegradable, environment-friendly, easy available, and its cost is very low. And because its cost is very low, because it can be extracted by the waste biomass. Cellulose can be extracted from the plants, animal, and the bacteria. Nowadays, most of the maximum cellulose researchers and scientists are trying to extract cellulose from the waste biomass, and that may be the waste plants and the waste biomass. As I said, nanocellulose is the nano part of the cellulose, and that is a natural fiber. Nanocellulose is a natural fiber that can be extracted from the cellulose by breaking intermolecular hydrogen bonding. For the nanocellulose, this is the very important and essential. It's one dimension, at least one dimension should be in the nano range. Normally, its diameter like less than the 100 nanometer and length may be in several micrometer. The morphology, particle size, crystallinity, all these parameters depends upon the method of the extraction. Your extracted nanocellulose is the hydrophilic, hydrophobic, yield. What are the yield of the nanocellulose? What are all the morphology that depends totally upon the extraction method of the extraction. Now, if you see the extraction of the nanocellulose is the shown by this picture. As you can see, biomass, lignocellulosic biomass is given to you. Lignocellulose biomass is consisting of the three main constituents: cellulose, hemicellulose, and the lignin. Okay. After the pre-treatment of the lignocellulosic biomass, you can see it will be converted into the cellulose fibrils. Okay. Then after the pre-treatment, it will be converted into the cellulose fibrils. And after that, cellulose extraction take place. After the mechanical, you can apply the by the cellulose treatment of the cellulose fibrils, it will be converted into the nanocellulose. CNC. There are the three types of your nanocellulose: CNC, CNF, and BC. Yeah, BNC you can say, both are the same. CNC. CNC is the cellulose nanocrystal, and that can be extracted from the cellulose fibrils by the acid hydrolysis. All these things, CNC, CNF, and the BC, depends upon the which kinds of your process you have to opt. If you are opted the acid hydrolysis, then you will get the CNC. And you must know, CNC has the high crystallinity. Cellulose fibrils is given to you, and if you can see, this had the cellulose chain, not only the cellulose chain, and cellulose chain had the two main regions, crystalline region and amorphous region. Amorphous region means what? That is not that is due to the presence of your hemicellulose and the lignin. After your acid hydrolysis, there will be the complete removal of the amorphous region, and now your cellulose chain will be converted into the nanocrystalline cellulose, because after the acid hydrolysis, your amorphous region from the cellulose chain will be completely eliminated. And finally, your cellulose fibrils will be converted into the nanocrystalline cellulose. Second one is the CNF. So CNF is a long, flexible, and intentional nanocellulose which can be extracted from the cellulose fibrils by mechanical method. CNF is extracted by the mechanical method, whereas CNC is obtained by applying the acid hydrolysis. As I said, crystallinity of the CNC is very high. There may be the complete removal of the amorphous region, and that's why their crystallinity is very high. On the other side, if you talk about the CNF, it has both crystalline and the amorphous region. It means what? If there is a not complete removal of the amorphous region. It means what? Crystallinity will be lower as compared to the CNC. Okay, to cellulose fibrils, after then it will be converted into the cellulose chain, and again cellulose chain is consisting of the crystalline region and amorphous region. After applying the mechanical process, it will be converted to the nanofibrillated cellulose, and that is the consisting both cellulose region as well as the amorphous region. Bacterial cellulose, bacterial nanocellulose, and it is produced by the bacteria. And it is the purest form from the nanocellulose without other component from the nanocellulosic biomass such as the lignins, hemicellulose, and the pectin. Bacterial nanocellulose is the purest form of the nanocellulose. No, it doesn't have any kinds of the impurities like the lignin, hemicellulose, and the pectin. Purest form of the nanocellulose. And it is produced by the fermentation of the bacteria. There are if you try to differentiate what are the difference between the CNC, CNF, and the BNC, cellulose nanocrystal, cellulose nanofibrils, and the BNC. So I have tried to make a table to differentiate all these three. Like if you talk about the CNC, the source of the CNC is the plant's fiber. It will be the jute, sisal, banana, kiraf, wood pulp, bamboo, cotton, a lot, and so on. CNF, same cheese. Plants fibers are also source for the CNF. BNC, as I said, BNC cannot be produced for bacterial nanocellulose, cannot be produced for your plant fibers. It is produced by the bacteria. Morphology. If you talk about the morphology of the CNC, that is the rod-like and highly crystalline. CNF, long and flexible fibrils. Bacterial nanocellulose, 3D nano scale fibrous network. If you talk about the size and the basis of the size and the size, CNC and CNF are categorized. Length, The length of the CNC is 100 to 500 nanometer and diameter 5 to 20 nanometer. But in the case of the CNF, length several micrometer and diameter is only 20 to 100 nanometers. This is important to understand. In the both cases, in the CNC and the CNF, only diameter in the nano range. On the other side, in the length in the case of the CNC in the nano range, but in the case of the CNF, that can be goes up to the several micrometer. BNC fiber diameter may be the 20 to 100 nanometer and length will be continuous. Crystallinity, as I did, CNC has a high crystallinity that can be goes from 50 to 88%. On the other side, the crystallinity of the CNF is the moderate, like the 40 to 70%. And BNC, as I said, BNC, bacterial nanocellulose, is the purest form of the cellulose, and it has no any kinds of the impurities. It means what? Its crystallinity will be the maximum, and that lies around 80 to 90%. Mechanical property. CNC, very high stiffness, around the modulus 100 to 150 gigapascal. CNF, high toughness and the flexibility. BNC, excellent strength. If you are looking for the modulus, then you should go with the CNC. If you are looking for your excellent strength, then you should go with the BNC. Surface chemistry, abundant OH group, easy chemical modification. CNF, high surface area. And BNC, highly pure, no lignin, and hemicellulose, easy to functionalize. But on the other side, there are some complications and limitations with the functionalization of the CNC and the CNF. Extraction method, as I said, you can use the acid, different kinds of the acid for the acid hydrolysis like the H2SO4 and the HCl. Nitric acid, some researchers have also used enzymatic hydrolysis also can be used for the production of the CNC. CNF, mechanical fibrillation, Camto, oxidation, grinding, homogenization. These are the some methods to produce the CNF from the plant fibers. And as I said, fermentation of the your bacteria can be used for the production of the bacterial nanocellulose. Okay, if you see, this picture is the showing how meter to nano scale, any conversion of the plants or the fiber and the waste biomass into the nanocellulose. A tree is given to you, and suppose one plant cell is extracted from the tree. The plant cell will be the completed of all the components. Then if you extracted the one microfibrils, the size of the plant cell, will be around 100 micrometer, and the other side, microfibrils, it has a size around 100 micrometer. If you talk about the microfibrils, that is again in the very smallest part of your fibrils, and it has a size around 1 micrometer, and now microfibrils will be converted into cellulose molecules, which has a size around 1 nanometer. Picture B is the how your nanocrystal is produced. How nanocrystal is produced. If you see the distorted region and your crystalline region is the shown in your first figure. After that, after the acid hydrolysis, distorted region you can see after the acid hydrolysis, amorphous region will be the overcome, And finally, it will be converted into the nanocrystals. In some cases, that depends upon the types of your acid and the concentration and the treatment time of the acid. Case. In some cases, it will be the completely amorphous region or the completely removed. In some cases, it is not completely removed. And the bacterial nanos, as you can see, the fermentation of the culture media, your bacterial nanocellulose, your bacterial cellulose fiber can be produced. If I talk about the properties of the nanocellulose, so you will be surprised to see the mechanical properties of the nanocellulose. It has the extremely high strength and stiffness. Tensile modulus is up to 1 to 2 gigapascal. Young modulus is around 100 to the 150 gigapascal. High stiffness as compared to the Kevlar and the glass fibers. On the other side, CNF are the highly flexible, whereas CNC provides rigidity because its modulus is very high. And one more thing, excellent reinforcement capability. CNC has an excellent reinforcement capability. If we are using the 1 to 5% reinforcement of the CNC in any polymer, it can provide better mechanical property. Okay, thermal property. Moderate thermal stability. Because degradation starts at the 200 at the temperature of the 200 degrees centigrade. Low coefficient of the thermal expansion. Low coefficient of the thermal expansion that is good for its packaging applications. That makes cellulose suitable for the electronics and the packaging applications. Acts as an insulator. Reduce heat transfer when added to composite. So nanocellulose acts as an insulator too. Chemical properties, high surface reactivity. Your contains abundant hydroxyl group for the chemical modification, allow grafting, esterification, oxidation, and the functionalization. Hydrophilicity, strong affinity to water due to the hydroxyl bonding. So this one is not good because your cellulose may be the hydrophilic and the hydrophobic. That depends upon the acid hydrolysis. But it has in the most of the cases, it shows the hydrophilicity. It means what? High strong affinity to the absorb water due to the hydrogen bonding. And that can be modified by using the chemical treatments to achieve hydrophobicity. High crystallinity. Morphological property. Diameter lies between 5 to 200 nanometers and the length for the CNC 100 to 500 nanometer, CNF several micrometers, and the BNC continuous fibers network. High aspect ratio. Normally CNC has the more than 10 aspect ratio, L by D ratio. Enables excellent reinforcement and the network formation. Aspect ratio is a very important parameter. You must understand, if aspect ratio is high, it means that shows high reinforcement capability and the network formation. And if reinforcement capability is high, then mechanical performance will be also high. So there is the advantage with the CNC or the CNF or BNC that they have the high aspect ratio. It means what? High, excellent reinforcement and network formation capability. High surface area. Again, all this process depends upon the extraction process, and a surface area is around 200 to 500 meters square per gram. Just try to understand. Its surface area is 200 to 500 meters square per gram. And I would like to add one more thing, that nanocellulose is more efficient and its performance is better in the many nanoparticles which are available at a very high cost. In this way, you can see nanocellulose is the maybe the better replacement of the nanoparticles which are available in the market. And if you are working in the area of the nanotechnology and the nanocomposites, I will suggest you you should try nanocellulose in place of the other nanoparticles due to its excellent performance and properties. Now, your next thing I would like to discuss, that is extraction of the nanocellulose. Extraction of the nanocellulose from the biomass is a two-step process. Mainly pre-treatment and the cellulose treatment. Pre-treatment, extracted fibers from the cellulose fiber. Pre-treatment, like maybe the dewaxing, removes dust and the oily substance. Alkalization, remove hemicellulose, lignin, and other constituents. And but I would like to add one more thing. Alkali is not capable to remove all the impurities. Bleaching removes the remaining hemicellulose, lignin, and obtain pure cellulose. So bleaching is applied after the alkalization for the complete removal of the hemicellulose and the lignin and to obtain the pure cellulose. So this process is known as a pre-treatment. Now, second step is the cellulose treatment. So you can see after the pre-treatment, you can get the cellulose fibrils, and cellulose fibrils is the consisting of the amorphous region and your crystalline region. So you can apply three things: mechanical process, acid hydrolysis, or the chemical treatment. If you are applying the mechanical process on your cellulose fibrils, then you can get CNF, nanofibrillated cellulose, CNF, cellulose nanofibrils. If you are applying acid hydrolysis, you can get nanocrystalline cellulose. If you are applying chemical treatment, then you can apply hairy cellulose nanocrystalline. Hairy cellulose nanocrystallites. If you talk, there is the many applications where nanocellulose are being used. And nanocellulose is being popular and a better replacement of the nanoparticles, which is commonly available in the market. Now, nanocellulose is playing very important role in the area of the nanotechnology because its excellent properties. Due to its excellent properties, it is being used in the many applications. Like you can see, the picture is showing the many different applications of your nanocellulose. Paper and pulp, composites, packaging, hydrogels, paints, filters. Nanocomposite materials, biomedical products, wood adhesives, electronic sensors, separation membranes, paints, and coating. Now, next thing is what are the source of the nanocellulose? As I said, the source of the nanocellulose is the most like it may be the plant fibers, agro waste, bacteria, algae, and the tunicates. Plant fibers like the jute fiber, banana fiber, different kinds of the natural fibers obtained from the biomass. And advantages of this plant fiber, that is abundant and the low cost and the renewable. Agro waste, if you talk about the agro waste like the sugarcane bagasse, straw, husk, rice like the rice husk, wheat straw, and these are the sustainable waste to the wealth. Bacteria, K. gelinus, that is the high purity and the biocompatibility. Algae. Algae is also a source of the nanocellulose, and it has a very high crystallinity. Tunicates, like the sea squirts strong cellulose, and it is not suitable, and the research is very less on the tunicates, and it is also very costly. As I said, I was talking about the source of the nanocellulose and your plant fibers. So you must know that there is a plant fibers. The plant fiber is consisting of the mainly three parts: cellulose, hemicellulose, and then lignin. In the any plant fiber, cellulose components, the cellulose is the major components, and that lies between 50 to 65%. Hemicellulose 20 to 40%, and the lignin 20 to 30%. But the important thing is these are the important constituents of the any plant's fiber. That is the cellulose, hemicellulose, and the lignin. The structure of the nanocellulose is shown in this picture. Now, it is very important to understand. As I said, there are the three main constituents of the any plant's fiber, like the cellulose, hemicellulose, and the lignin. So just try to understand what are the function of your cellulose. Cellulose provides strength and rigidity to the plant cell wall. Forms microfibrils that acts as a reinforcing rods, gives the tensile strength, maintains cell shape and integrity, supports plant's growth and the upright posture, acts as a barrier against the external stresses, forms the main backbone for the nanocellulose structure. As you know, the nanocellulose is nothing but the nano size of the cellulose. That's why cellulose is the main backbone for the extraction of the nanocellulose. Lignin provides a compressive strength and acts as a cementing material, binding fibers together. Make the cell wall rigid and obedient. Provides hydrophobicity. Provides water resistance to the cell wall. And lignin also protects plants against the microbial attack and the decay. So cellulose is a very important component of any plant's fiber. Hemicellulose binds cellulose microfibrils together like a natural glue. Provides flexibility and elasticity to the cell wall. Acts as a matrix that embeds cellulose. Helps in the cell wall hydration. Water holding capacity is just possible due to the presence of the hemicellulose. Facilitates transport of the nutrients and the waters. Stabilizes cell wall structure by the cross-linking with the lignin. Controls cell wall porosity. If you're talking, as you know, if we are talking about the source of your nanocellulose, so nanocellulose plant fiber is the main source of the nanocellulose. And plant and the examples of the plant source is the natural fibers. One thing I would like to discuss. So what are the advantages of the natural fibers? You should also start. Natural fibers is the main source for the extraction of the nanocellulose. So you should know what are the advantages and the characteristics of the nanocellulose. Why it is important? And you know, cost is the cost of the nanofibers. Natural fibers is almost negligible as compared to the synthetic fibers. And undoubtedly, if you're talking about the medium strength applications, then natural fibers are the better replacement of the synthetic fibers. Due to its excellent characteristics like density. Density of the natural fiber is low. On the other side, the density of the synthetic fibers is around twice of the natural fiber. Origin. Natural fiber is naturally produced, and synthetic fibers are produced by the man. Fiber structure cannot be changed, and structure of the synthetic fiber can be changed. Nature. The nature of the natural fiber is hydrophilic. On the other side, the nature of the synthetic fiber is hydrophobic. Durability, natural fiber low, synthetic fiber high. Cost low, natural synthetic fiber high. Renewable, natural fibers are renewable. Synthetic fiber are not. Recyclability, yes, no. Energy consumption in the natural fiber low. For the synthetic fiber high. CO2 neutral for the natural fiber, yes. Synthetic fiber, no. Health risk for the natural fibers, no. For the synthetic fibers, yes. Biodegradable, natural fibers are the biodegradable. Synthetic fibers are the not biodegradable. Decomposition of the synthetic fiber is the major challenge. Specific strength and the modulus of your natural fiber is very high as compared to the synthetic fibers, which make the better replacement of the synthetic fibers. But strength and the modulus of the natural fiber is low as compared to the synthetic fibers. But important thing is the specific strength and the modulus of natural fiber is high because the density is low, almost half. One word I use like that, if you see the CO2 neutral, for the natural fibers, it is yes, and the synthetic fibers, it is no. What is the meaning of the CO2 neutral? So I would like to explain what is the meaning of the CO2 neutrality of the natural fiber. Its meaning is very simple. CO2 observed during the growth of any plant is equal to the CO2 release at the end of the life. If you are burning the plants, then CO2 will be released. And the amount of the released CO2, that will be equal to the CO2 observed during its growth. That's why we are saying this is the meaning of the CO2 neutrality. It means what? It is not increasing the CNT content in our environment. That's why it can be considered as a sustainable material. And because net effect is zero, because zero increase in the atmospheric CO2. There is zero increase in the atmospheric CO2 on the burning of the natural fibers, because it has already observed CO2 in the more amount during its growth as compared to the release at the end of the life. Another aspect, if you try to understand this, a carbon footprint compared to the natural fiber and the synthetic fiber, if you see the carbon footprint of the natural fiber is very low as compared to the synthetic fibers. If you see the jute, the carbon footprint for the jute, that is 0.5 to 1.4. On the other side, glass has 10 to the 16. And for the carbon fiber, its values increase from 20 to the 40. This table also shows that natural fibers is better for the environment as compared to the synthetic fibers. If you talk about the bio-nanocomposites, so there is a composite, that is there are mainly two constituents, reinforcement and the matrix. If reinforcement is the natural fibers and the matrix is the polymers, so such type of the composites is known as the biocomposites. And if the natural fiber size are in the nano range, then biocomposite will be converted into bio-nanocomposites. If you are using as a CNC CNF, and a BNC as a reinforcement material, then your composite will be known as the bio-nano composites. Bio-nano composite, it may be the partial biodegradable and the completely biodegradable. Depends upon the what kinds of the polymer you are using. If it will be the partial biodegradable, if you are using the nano cellulose with the non-biodegradable polymer, and it will be the completely biodegradable if you are using the nanocellulose with the biodegradable polymer. And completely biodegradable polymers will be known as a green biocomposites. And green bio-nanocomposites and green biocomposites are the completely safe for the environment because they are the completely biodegradable. Now, a very important aspect, that is the additive manufacturing. If you talk about your fabrication of the composite materials, so there are the number of the process for the fabrication of the composite materials that depends upon the application, types of the fibers, types of the structures of the fibers, size of the fibers, orientations of the fibers, types of the properties of the polymers. But nowadays, additive manufacturing is also being used for the fabrication of the composites. Additive manufacturing is a process of, as you know, it is a process of a fabrication 3D object directly from the CAD model by adding the material layer by layer. And it is opposite to the your machining process, because in the machining process, material is removed, and your additive manufacturing material are deposited layer by layer. First 3D technology was developed in the 1987. That was the SLA, stereolithography. Additive manufacturing can be classified based on the solid base, liquid base, and the powder base. Solid base, FDM, WAM, and LOM. For the liquid base, SLA and the polyjet. Powder base, SLS, SLM, and LMD and EB. In one of my research, I used the FDM process for your fabrication of the nanocellulose reinforced filaments for the 3D applications. So the picture for the FDM process is shown to you. So I'm not going to details. Just I want to show you what are the advantages. Wow, nanocellulose what is important for the 3D printing applications. So huge FDM process are used in my research. When one of my PhD student worked on it, he prepared the nano filaments using the nanocellulose, and that was extracted by the cellulose your sisal fibers, and then by nanocomposite filaments preparation. So in this work, as you can see, the PLA was the matrix and the CNC was extracted from the cellulose fiber. Okay, so first of all, the filaments were prepared, and you can see the filaments will be prepared how? Using the extruder. First of all, PLA pellets and the CNC both were mixed in the ball milling. Then it will be inserted into the extruder, and finally you can see the filament of this polymer reinforced CNC are prepared by the extrusion process. So in this research, we have taken the concentration of the CNC 1%, 3%, and the 5%. And as you see, the reinforcement capacity you can use for the cellulose 1 to 5%. So we have taken 1%, 3%, and the 5%. So if you like to see the crystallinity of the PC1 means the composite having the 1 of the nanocellulose, crystallinity goes up to the 60.93%. Tensile test of the filaments, and you can see the PLA having, if you compare with the tensile strength of the bionanocomposites with pure PLA filaments. The pure PLA filaments having the tensile strength that is the 36.1 megapascal. In the other side, on the reinforcement of the 1% CNC into the PLA, it values goes up to the 48.9. So it is very important to observe the PLA filaments is the showing tensile strength that is the 36 megapascal. And after adding the 1% of the nanocellulose, its value goes to the 48.9 megapascal. Huge increment. Okay. Thermal property, you can say glass transition temperature was also not very affected, but it is important to see the glass transition temperature is above to the 70 degrees centigrade. So you can use the composites of the nanocellulose that is best suitable up to the temperature of the 70 degrees centigrade. Next is after the preparation of the filaments were further used for the 3D printing of your samples by using the FDM printer. As you can see, the filament is used for the FDM printer and the 3D printer sample were prepared and for the further characterization. And these are the 3D printed sample for the tensile test, flexural test, and impact test. And the 3D printing parameters were set for this testing. I'm not going to discuss all these things, but important thing is that which I will to discuss. And now, if you see the bionanocomposites, its strength goes to the for the 1% of the reinforcement, its strength goes up to the 46.1 megapascal. Flexural strength is increased after the reinforcement of the 1% up to the 61 megapascal from the 49 megapascals. Impact strength was also improved by 10 kilojoule per meter square to the 17 kilojoule per meter square after the reinforcement of your nanocellulose. So I would like to suggest you that there is a lot of score of the research of the cellulose, nanocellulose, and its bionanocomposites. And if we are applying the 3D printing for the fabrication of the bionanocomposite, so there is a lot of innovation, a lot of scope, a lot of gaps for the research in this area. Suppose if you are trying to start your research, so there is a big challenge. If you're trying to publish a paper, there is a big challenge. What is the novelty in your work? What are the research gaps? So I would like to suggest you that if you are working in the area of the composite materials, then you can work in this area. There are some challenges in the what I face during the preparation of the filaments by the extrusion, that is the poor dispersion of the nanocellulose in the hydrophobic PLA. The problem is the poor dispersion. The main reason of the poor dispersion of the nanocellulose was the nanocellulose has a hydrophilic nature, and the other side, PLA has a hydrophobic nature. So there is a poor compatibility between nanocellulose and the PLA as a result in the poor dispersion of the nanocellulose. Moisture sensitivity of the nanocellulose. Nanocellulose observe water or the moisture very quickly. Even 2 to 5% moisture can cause PLA hydrolytic degradation during the extrusion, decrease in the molecular weight and the viscosity, poor printability, and the reduced mechanical strength. So we should try to avoid the water absorption by the nanocellulose. Thermal degradation. Nanocellulose being thermally degrade near the 200 degrees centigrade, and a PLA mild processing occurs at 170 to 200 degrees centigrade. So as you can see, there is a very narrow safe window. Poor interfacial bonding without the compatibilizers. If you are not using the compatibilizers, then there will be the poor interfacial bonding of the nanocellulose with the PLA. For this, you should go with using of the suitable compatibilizers for the strong interfacial bonding between the PLA and the nanocellulose. Difficulties in the controlling the filament diameters. Extruders of the filled PLA often leads to the swell, instability, non-uniform cooling, diameter variation outside. Mixed filaments are unsuitable for the FDM printers. So from my side, it is over. Dr. Rohit. Hello, Dr. Rohit. Am I audible to you or not?
Yes, sir.
Dr. Rohit, from my side, it is over.
Yes, sir. Participants are requested to ask any question if they have. Sir, some questions are there in chat box. You can see the questions also.
I will reply. I will reply later on if there is any question. Okay.
If any participant have any questions, we have a great opportunity and an eminent speaker with us. You can ask any question from sir. The stage is open to all of you.
Okay, Dr. Rohit. Hello.
Yes, sir. Sir,
Okay.
some questions are there in the chat box.
Okay, I will reply later on. No,
Okay, sir.
Okay, I will reply later on. Okay, I have to reply at this now, or I can reply later on.
So verbally you can reply now. There is no problem.
Okay, let me see.
Some questions are there. Extraction process is eco-friendly.
Let me check. Oh. No, there is no any question here. No, there is no any question.
Okay, sir.
There are some comments. Okay. Okay. So Rohit, you can share my numbers and mail ID if
Yes,
any
sir.
students have any queries. So he can discuss with me personally.
Okay, sir.
Okay.
Okay, sir. Okay, thank you very much, sir, for your insightful and enriching session. On behalf of Department of Mechanical Engineering UCR Prayagraj and the Atal AICT FDP organizing team, I extend my sincere gratitude to Dr. Manoj Kumar Gupta, sir, for sharing his valuable knowledge and expertise with us today. Your session has greatly enhanced our understanding and added significant value to this program. We are truly honored to have with you us. Thank you once again, sir. Thank you for such a knowledgeful session, sir. We are looking such sessions in the future endeavor also, sir. Thank you, sir, for accepting our invitation. Thank you very
everyone.
much, sir.
Thank you so much, Dr. Rohit, and thank you to all of you. Thank you very much to each and everyone. And one more thing, dear students, you can take my WhatsApp number, my number, email ID, and I will be more happy if you will try to work with me. Any of you can call me, mail me for any collaboration, any help, any discussion, anytime. Okay?
Yes, sir. Thank you so kind of you, sir.
When I leave, Once again, thank you all. Thank you so
Thank you,
much.
sir. Thank you very much. All the participants, good night, sir. All the participants are requested to please see the feedback link in the chat box and please fill it on urgent basis before leaving the session. Uh, There's a time of 15 minutes for all of you. You can fill the feedback. You all have 10 minutes more to fill the feedback link. The link is also shared in the group also, WhatsApp group also. Okay, all the participants, I hope that you have found the feedback link. So for now, we are closing the today's session, day 3. It's a wonderful session from both the speakers, and we are very thankful to all the participant dignitaries and esteemed resource person which have shared a wonderful knowledge with us. Now we will move tomorrow at the same time, 6 p.m. with another two eminent speaker. Till now, good night to everyone. Good night, participants and respected faculty members all over the country. Good night, sir. Good night to all of you.
Good night, sir.